Hey guys, Mr. Harrelson here again for our space science lesson. This is going to be a review of what we have learned so far. Waiting for it to load up there. And then we're going to go on to part two of space science. So on these first couple lessons, we've really focused on scale and size, how far are objects like the moon, the sun, how just basically like how big is space, and just kind of getting to know our place in the universe a little bit. Just kind of scratch the surface. We've looked at just how vast and big things are, and in the upcoming space lessons, we're going to look at things like constellations and the other stars and just how far they are and how we can tell how far they are. We're going to look at how gravity works, and we're going to look at the Earth's shape. Yes, it is shaped like a ball. It's not flat, so we'll talk about that. And we're also going to look at why we have different seasons and night and day on the Earth, and how the orbit works. So that's all upcoming. So we're going to have a review. I'm going to post another video for you guys to watch. And in a little bit, I might have a little Google quiz for you to fill out. It's not going to be anything big. I think I'll post that either later today or tomorrow. So yeah, sit back, relax, and let's review some of what we've talked about. Okay. All right. So remember, in space science and like in all types of science, we use models. We have 3D models. These are the really fun models that really help us kind of picture the different shapes of things, and they're usually to scale if they're done well. Sometimes they're not always accurate. So all models can be inaccurate and accurate in different ways. So they can be correct and incorrect. So like my Lego Saturn V rocket, it looks like the real deal. It looks very impressive, but if obviously the real rocket's not made out of Legos, right? So that's an inaccuracy on it. It doesn't have an engine. I can't let that rocket fly into the sky or space. We use 2D models a lot, especially what you're seeing on the screen right now is an example of a 2D model. Drawings, computer animations, are 2D, what we use to look at something like this very inaccurate drawing of the solar system. As you can tell, the sizes are all off, especially compared to the sun on there. And then, of course, we use math models to model our thinking, to show algorithms to show how math is working. And one way that we model our Earth and our moon is a basketball and a tennis ball. So if you remember early on, we were showing if the Earth was the size of a basketball and soccer ball are about the same size, and the moon would be about the size of a tennis ball. And then I asked you to think about, well, how far would the moon be from the Earth if that were the case? So it would be pretty far. So we often see these drawings of the moon very close to the Earth, but it's far, but not nearly as far as the sun. So the sun is much further and much bigger than us. So then our next model was, okay, so the sun's a soccer ball. We're represented by the soccer ball. And what would the Earth be the size of? And you remember this from last time, and the answer is the peppercorn, about the size of a peppercorn, the Earth. And, over 1 million Earths could fit into a sun, which is really mind boggling. And that's why we use models to help us wrap our heads around just how big and how far these things are. And then if you wanted to show how far that is, well, you're going to need to hike out into a soccer field or football field just to even show that distance. And here's another example here. Let's hide this guy. Our model of the sun and just how tiny the Earth would be. And then it shows the other planets here. This is showing you not how far they are from the sun, but their size compared to the sun. So remember that the sun is a star, and it's the only star in our solar system. It is the center of our solar system, and all planets orbit it. And why did they spin around the sun? Well, that's because of gravity, and we'll get into that a little bit more. So the sun is the only star in our solar system, even though when we look out into the night sky and we look into space, we see other stars. They're not in our solar system. They are in our galaxy or in our universe. They're within our own galaxy. And so if you remember from those videos, when we were going further out, not just our galaxy, but there's other galaxies out there as well. So again, how do things like this happen? The total solar eclipse. Why does the moon appear to be about the same size as the sun? And they're not exactly, but they're pretty close. And a lot of you know the answer to that by now, hopefully, is that the moon, while it's still pretty far from us, is much, much, much closer to us than the sun. And the sun is super, super far away from us, about 93 million miles from us, and super, super huge. And it acts just like it's all about perspective, right? It's just like those pictures where you have something small close to the camera and something large far away. To us, the sun and the moon appear the same size because the sun is super huge and super far away. The moon is much smaller and much closer to the earth than the sun. And again, here's the example of perspective. This is that same idea of the moon and the sun. So remember, the moon's much closer to the earth, although still kind of far away, and the sun is very, very far from the earth. And then our examples of perspective photography here. A couple of people shared those, and hopefully we'll share those again later on. And maybe some more people will have some to share at the Zoom meeting. Here's a image I want to leave you with today, just showing the orbits of the different planets. The video I put in for today's review goes into each planet a little bit and the order of the solar system. We haven't focused on that so much yet. You're going to have a chance to independently research a planet and write about it with Miss Adderley if you want to. So we'll get into that a little bit, but it's showing from with the sun in the center there and the other planets orbiting, starting with Mercury, then Venus, Earth. So we're the third planet from the sun, followed by Mars. And then in between, we have that asteroid belt, which is not a planet, but a bunch of asteroids there. And then we get to Jupiter, the largest planets. These are all gas giants now. Saturn with its rings, the beautiful Saturn. After that, Uranus out here, that teal green color. And then finally, Neptune. And back when I was a kid, Pluto was still a planet, but it's kind of considered a dwarf planet because they're not even really sure. It's so Pluto would be even further out there and just very, very tiny. So, all right, guys, enjoy the review. Just watch the video and fill out the little, it's like a Google quiz later on today. All right, bye.